All right. So in any hypothesis testing question, guys, you have to state the null and the alternative, decide where the claim is. After that, you have to find what we call a test statistic. It is a Z or a T. It is a Z if we use the normal distribution. If we're testing the mean, it is a Z if sigma is known. If we're testing the mean, it is a T if sigma is unknown. Then you will find the p-value. The p-value is the probability between 0 and 1. You compare it with the level of significance alpha. If the p-value is less than alpha, you reject HO. And if the p-value is more than alpha, you fail to reject HO. And now the challenge, guys, I received emails from students that they still have a trouble in writing the conclusion to select the proper conclusion, which is step number 5. So I prepared this for you. And just to keep it handy, guys, as I go through the materials today, you can take a screenshot of this one right now. So there are 4 scenarios, and they are shared with you in my handouts under resources by your instructor, but I'm just going to go over them. The first scenario is your claim is in the alternative hypothesis. If you end up with the claim being in the alternative hypothesis right here, guys, in HA. And if you reject the null hypothesis, if you reject HO, and your claim is in HA, you support the claim. Because you reject the first one, that means the second one is good. So you're right. There is enough evidence at the alpha level of significance to support the claim, whatever the claim is. Now, if you fail to reject HO, that's a second scenario, and your claim happened to be in HA, you say, I cannot support the claim. So when your claim is in HA, guys, you have to use the word language of support. Support, support. You have to use this. Remember, when you fail to reject, there is a not here. When you reject HO, you don't see the not. There is enough evidence to support the claim. So these are 2 scenarios. There are another 2 scenarios, guys, that we haven't done much of because most of the questions we ended up having the claim in HA. But what about if the claim is not in HA? What about if it is in HO? So watch here. If your claim happened, probably the question you ask me, how do I know if the claim is in HO or HA? Well, it depends on the question. If the problem say test that the proportion equals 15%, that means the claim is in HO because equal means in HO. So if the claim is in HO and you reject HO, you reject the claim because the claim happened to be HO itself. So you're right. There is enough evidence at the alpha level of significance to reject. You notice, guys, that when the claim is in the null hypothesis, we use the word reject. We don't use the word support. If you fail to reject the null hypothesis, then you're right. There is not enough evidence to reject the claim. These are the 4 scenarios. You're going to notice every single problem I do, I have to choose one of the 4 at the very end. It's either this or that, or either this one or that one. What I'm going to do today, as I do step number 5, I'm just going to come back to this and show you how to select, the conclusion, because the conclusion is very, very important. Actually, it is the most important thing in the hypothesis test. What would you conclude in words that people can understand? All right. Now, guys, I'd like you to remind me of I think we did want to, can you guys tell me what question we ended up with the last time? Did we do number 5 in the practice sheet? Do you guys, can you recollect if we did this? Anyway, guys, I'm gonna do all the questions. Well, actually, let me just review this with the t-test. I'll review it. I think we did that last time. I will review that with you. Maybe I'll review it just a couple more, and then I'll do all the proportion tests from section 7.4 to do a good review of section 7.4. Okay, let's look at this one. Number 4. I will scan all of those documents as soon as I finish with you at 2 today. Yeah, I remember we did that and changed the 3.5 to 3.4. A fast food outlet claims that the mean waiting time in line is less than 3.5 minutes. A random sample of 15 customers, so N is 15, has a mean of 3.4 with a standard deviation 0.6. Guys, he didn't mention population standard deviation, so the 0.6 is S, not sigma. If alpha equals 5%, test the food outlets claim. Okay. Well, what is the claim? They're claiming that they can serve the mean waiting time is less than 3.5 minutes. You can see here, guys, less than 3.5 minutes. This is the claim. Look, the null hypothesis is the total opposite, so it will be greater than or equal to. Since S is giving, it is a t-test, and let's plug in the stuff into the calculator and show you how to do the t-test here. Stat. Oops, sorry. T-test. Okay. Mu 0 is against 3.5, guys. X bar is 3.4. S is 0.6. And N is how many? 15. And we're testing that the mean, the alternative hypothesis is less than. Before you hit calculate, you have to select the alternative hypothesis. And if you hit calculate, T is negative 0.645 and P is 0.2645. There you go. The 0.2645, guys, is bigger than alpha, which is, what did he give us, alpha? 5%. You fail to reject the null hypothesis, and let me show you. We failed to reject HO. I'm gonna go back to my yellow sheet. The claim is in HA. We failed to reject HO, look what we write. There is not enough evidence at the 5% level of significance to support the claim. Watch. There is not enough evidence at the 0.05 level of significance to support the food outlets claim. All right. Number 5. Carolina Tobacco Company advertised that the best-selling non-filtered cigarettes contain at most 40 milligrams of nicotine. So they say we don't have more than 40 milligrams of nicotine in our cigarettes. But there is a consumer advocate magazine ran tests of 10 randomly cigarettes and got the following data. It is a serious matter to charge that the company advertising is wrong, so the magazine editor chooses alpha equals 0.01. Can the editor prove that the mean nicotine level is greater than 40 milligrams? Greater than 40 milligrams, guys, it's right here. That's the claim. It is in HA, and this is the null hypothesis. Okay, what I did, or what we did last time, we put the data in L1, and then we run a t-test. Watch. And instead of stats, you have to use data. Mu0, we're doing it against 40. L1, don't change the frequency. And the editor think that they have more than 40 milligrams. And hit calculate. Okay, so T is 2.746 and the p-value is 0.0113. There you go. More than alpha. Fail to reject HO. And let me go to my yellow sheet. Claim is in HA. Fail to reject HO, guys. Here's what you say. There is not enough evidence at the 1% level of significance to support the claim of the editor. That means the editor is wrong. Probably the tobacco company can go back and sue the editor or the magazine. All right. Next, number 6. I think that was, we did that one as well. The engineering school at a major university claims that 20% of its graduates are women. So now it's a percent. In a graduating class of 210 students, 46 were women. Does this suggest that the school is believable? All right. So the claim here, guys, that P is then 20%. So now the claim is in HO, not in HA, so which is good because I want to show you the other two scenarios. So the alternative will be not equal to 20%. Okay. This is a proportion. It's a proportion z-test. This is the sample size, which is 210, and this is 46 out of the 210 were women. This is what we call it X, the number of successes. In order to run a proportion z-test, you have to verify two requirements. If he doesn't ask you to verify them, you don't need to verify them. But let me tell you what the two requirements are. NP is greater than 5, and NQ is greater than or equal to 5. How do you verify them? Like this. N is 210, and you take this right here. That's the P. Well, if you guys multiply, you're going to get a number bigger than 5, so that's verified. Then Q, you take 210 and multiply by Q, which is the probability of failure, which is 0.80. And definitely, guys, if you multiply, you're going to get a number greater than 5. So the requirements of the test are met. Just like in proportion intervals, when we did the interval proportion, these are the requirements. Okay. How do you run this test? Let's go back. Stat. Proportion z-test. P is 0.20. That's the value on the null hypothesis. X, guys, is 46. N is 210. And not equal to, this is the alternative sign, and let's hit calculate. Z is 0.69, and the p-value is huge, guys. It's a 0.49015. Had I done the draw, you will see how big the p-value is. Watch. Oops. That's that. Let me do it one more time. Proportion z-test. I'm just going to hit draw. See, that's the p-value of 0.4902, which is bigger than alpha. You fail to reject HO. Now watch, guys. The claim is in HO. We're here. And we fail to reject HO. So what do? I say there is not enough evidence to reject the claim. This is going to be a challenge for you guys to decide whether you reject or fail to reject the claim, or support or fail to support the claim. These are the 4 scenarios. If you have them handy, understand them, nothing will go wrong. Fail to reject HO, then you say there is not enough evidence at the alpha level of significance to reject the claim. You see, the word reject must be used when the claim is in HO. Number 7. I don't think we did that last time, so I'm going to do it right now. Any Boston Celtics fan knows that Shaquille O'Neal, one of the NBA's most dominant centers of the last 20 years, always had difficulty shooting free throws. Over the course of his career, his overall made free throw percentages is 53.3%. So he is successful 53.3% of the times. During this off season, Shaq is working with an assistant coach on his free throw technique. During the first 5 games of the next season, Shaq made 26 of his 39 free throw attempts. So he was successful 26 times. Do the results provide convincing evidence that Shaq has significantly improved his free throw techniques? Use alpha equals 0.05. Would one of you please, guys, tell me what should HO and HA be here? We want to see if he improved. How would you word this one in terms of the letter P? Any suggestions, guys? I'm listening. what should the alternative and the null hypothesis be? Any ideas? Yes?
False.
What is it?
Equal.
We want to see if he improved. Improved means more than what he had before, more than 53.3%. And you've changed it to a decimal, it's 0.533. That's the claim. And that's a less than or equal 0.533. Okay, you got X, guys, and you got N. That's all you need. X is the smaller number, N is the bigger number. And let's run a proportion Z test. Did I leave room for it here? No. So one prop Z test. Ready? Okay, let's do that. Stat tests. One prop Z test. Okay, we're testing again 0.533. X is 26. N is 39. And we want to see if he improved. Improved means bigger, so greater than, and let's hit calculate. So Z is 1.67. I'm going to write it down. And the p-value is 0.0471. Is 0.0471. If you ask me, guys, about the 5 steps, always. First step, second, third. And now, this is less than alpha, which is 0.05. We come to the fourth step. We reject the null hypothesis because the p-value is less than alpha. Now, your claim is in HA, guys. Let me take you back to my yellow sheet. We're here. Sorry. Claim is in HA, and we reject HO, so there is enough evidence at the alpha level of significance to support the claim. There is enough evidence at the 0.05 level of significance to support the claim. And what is the claim if you have to write it down? That Shaq has significantly improved his free throw shootings with the training. So it did work. Next, number 8. A drug manufacturer claims that fewer than 10% of patients who took its new drug for treating Alzheimer's disease will experience nausea. Can you guys help me state the null and the alternative here? If you don't want to talk, it's okay. Just send it in the chat. What would be the null and the alternative, guys? No suggestions? Less than, okay. That is correct. That's the claim, and you know this one is the null. Remember, guys, HO must have one of those, and HA must have one of those. No, these two together, these two always together, and these two are always together. No other choices. Okay, I got in a random sample of 250, so N is 250, 23 experienced nausea, so X is 23. Perform test at alpha equal 5%. One proportion Z test, guys, as simple as that. There you go. Stat. One proportion Z test. Okay, we need to test against 20, what is it? 10%? 10%. X is 23. N is 250. and we're testing that P is less than. I'll do a draw here for you, or calculate, it doesn't matter. So Z is negative 0.42142. Once you're done with me today, guys, go back and redo those problems, and at least you got the answers so you can verify whether you're doing the right thing on your own. I mean, watching me doing the thing does help, but you need to supplement that for sure. This is bigger than alpha. Fail to reject HO or H naught, or the null hypothesis. Okay, let me go back to my favorite yellow sheet. Remember, the claim is in HA, guys. Watch. Claim is in HA, and you fail to reject HO. So what do you say? There is not enough evidence to support the claim. There is not enough evidence at the 0.05 level of significance to support the drug manufacturer. So maybe their claim is wrong. That fewer than 10% of patients who take their new drug for treating Alzheimer's disease will experience nausea. Number 9. It was found that 821 crashes of mid-sized cars equipped with airbags, 46 of the crashes resulted in hospitalization. So this is N and this is X. Resulted in hospitalization of the drivers. Using a 0.01 significance level, so alpha is 0.01. Test the claim that the airbag hospitalization is lower than 7.8%. Lower, guys, means less than. So he wants us to test this claim. P, anytime he talks about percent, it's a P. 7.8% changes to a decimal, 0.078. And that's the claim. All right, it's again one proportion Z test. And just do it with me, guys, as I go over it. Stat number 5, it is number 5 on all calculators, 0.078. We got 46 and we got 821. And we're testing that it is lower. And let's hit calculate. Z is negative 2.35. P-value is, there you go, I'll show it to you again. 0.0095, which is less than alpha for sure, guys. You reject HO. Okay, let me go back to my yellow sheet. Claim is here. You reject HO, what do you say? There is enough evidence at the alpha level of significance to support the claim. There is enough evidence at the 0.01 level of significance. The level of significance, guys, is the maximum allowable probability of making type 1 error to support the claim. So we can support the claim. The claim is valid that the airbag hospitalization is lower than the 7.8% rate. Now I want to bring your attention to something very, very important here if you come across it as you do your homework. Let's say instead of 46 here, he put something else. He put this. Please pay attention to that. So there is no 46, guys. 46 is not there at all. I'm just going to hide it. It was found that 821 crashes of mid-sized cars equipped with airbags, 6.5% of the crashes resulted in hospitalization of the drivers. Using a 0.01 significance level test, the claim that the airbag hospitalization is lower than the 7.8% rate. Does anyone know what to do here? We go to the calculator. We know it's a proportion test. We put the 0.078. Oh, and then we come here, we get stuck. If you put this, that will be wrong, guys, 6.5%. That's not X. That's a sample proportion. X is a whole number. It's a number of successes. Any ideas how to figure out X? He gave it to you in the previous problem, but what about if he gives you a percentage instead of X? What would you do? Exactly. I got a student telling me that you take the 0.065 and multiply by 821. Perfectly correct. So if P hat is giving instead of X, to find X, you do X equals N times P hat, which is in this case, let's say 821 times 0.065. But let me just do the math and see what number I'm going to come up with. 821 times 0.065. Okay, I got 53.365. Remember, X is a number of successes. It's a discrete number. You cannot put a decimal. You put a decimal into the calculator, it's going to halt. It's not going to do it. You round it. Round to nearest whole number. Just in case. I'm not saying you do this in this problem, but I just changed the problem. So you get 53. And then, guys, you do this. You go to stat, tests, number 5, one proportion z test, 0.078. You could do 0.065 times 821, but you need to round it. So it's 53, and then you do the test. It's going to work. Look what happened if I put 53.365. If you leave it like that, watch. It's not going to like it. It's an error. It won't work. All right. So in the case, if you are given a percentage instead of the X value, guys, this is what you do. You just multiply the percentage by the sample size, and then you get the number and just do the same work. All right. Let me just, so this is, okay, we did this. Now let me show you some, I'm gonna go over the critical value approach in 1 second, but let me just go over some examples that I made available to you guys right here. So you got some examples. You find it under resources by your instructor. It says chapter 7 using the calculator. Worked out examples with calculator screenshots. This is for the Z test when sigma is known. And just to show you where sigma is known, guys, let me just read it. Look, it says with a known standard deviation of 2.3. So it is a population standard deviation. So I got 1, 2, several exercises worked out. Check them out. This is another t-test, guys, and proportion z-test. And then I included 2 pages on how to use the calculator in chapter 7, using the TI 84 plus series in chapter 7, with directions, step by step. And this is my yellow sheet that I've been talking about. 4 scenarios. If your claim is in HA and you reject HO. So if you, either this or the yellow sheet, I did this, the summary in how to conclude the claim. All right. Any questions, guys, before I do the critical value approach? So you can do this exercise in the homework, and then we're going to proceed to chapter 8 recording. So we're doing an exercise now, not using the p-value, but using the critical value approach. This is from section 7.3, and actually the exercise in the homework is from section 7.3 as well. The amount of water consumed per week by Montana residents is normally distributed with a known mean. A simple random sample of 26. Okay. Of 26, n is 26, has a mean valued at 120.3, with a standard deviation of 10. Didn't mention, guys, population standard deviation, so it is S. The city of Bozeman claims that the average water consumed in the state of Montana is not 125. So we agree that the claim, guys, that we need to test that the mean is not 125. So step number 1, whether you use a p-value or you don't use it, it's exactly the same. Step number 2. So we did step number 1, which is HO. I'm going to just do it on a clean page here. Okay. Step number 2, if you go to the t-test, they will give you the test statistic t. But I'm going to show you that you could have done that also by hand if you want to do it. The formula is x bar minus the mean divided by s over square root of n. So x bar, guys, is 120.3 minus the mean, which is this value always. We assume it is true until proven otherwise. S is 10 over square root of 26. Well, I'm not going to do the math, but if I do it, guys, it's going to be negative 2.397. It's exactly what we have there. So here you can go to t-test and plug in the values and get it, but this is how you do it by hand. Now the critical value. The only difference between what I did before and what I'm doing now is step number 3. It's called the critical value approach, not a p-value. So I'm not going to find the p-value. Let me show you how the critical value works. All right, watch. You draw the curve, the t curve. This is a t, remember, because s is given. So I'm going to label it as t, not as z. This is 0. Okay. Because this is a two-tailed test, there are 2 rejection regions, one on the right and one is on the left. Okay. The area of the 2 rejection region is the alpha that he gives us. And what did he give us as alpha here? He says use 0.01. So this is half of alpha, guys, because it's a two-tailed test, and this is half of alpha because it's a two-tailed test. The critical value approach is asking us to find this value right here. Once you find one of them, guys, the other one is going to be a negative because they are symmetric. So I'm going to show you how to find the critical value, which is called the critical value CV. They call it in the book T sub 0, a critical value approach. Once I find this value, I will show you how to use it to make a decision whether you reject HO or fail to reject HO. Remember, when we did the p-value here, we ended up with the p-value 0.0244, more than alpha, we failed to reject HO. We should get the same result whether I use the critical value or the p-value. So watch. Okay, all I need alpha and I need the degrees of freedom. The sample size, guys, was 26, so the degrees of freedom will be 25. And let me show you how you would do this. This is table 5. Critical value, this is the table of the critical values. You need the degrees of freedom, which is 25. I am right here, guys, and I draw a horizontal line. Now look, this is for chapter 6. The first row was reserved for chapter 6. No more the case. Now we're chapter 7. Either a one tail or two tails. I think you should agree with me that this is a two tails, guys. Watch. It's not equal. So that is a two tails. If it is a two tails, you look here. And for alpha. And my alpha is 0.01. If you draw a vertical line, drop it until you hit the 25, you can see what alpha is, what the critical value is 2.787. So just put it here. $2.787. And this is like it, guys. It's a -20, -2.787. Okay. How do we make a decision to reject a null hypothesis or fail to reject a null hypothesis? Watch, it's very easy. You go to step number 2 and bring this number and put it on the number line. If I put this number on the number line, guys, would you agree with me that it's going to be somewhere here? Well, you notice this number did not fall in the rejection region. The rejection region is this area here, or this is here. The -2.397, it's to the right of the rejection region. It's not inside the rejection region, so you fail to reject HO. If this number, guys, was, let's say, -3.1, -3.1 would have been here. So then you would reject the null hypothesis. But in this case, no, it is the -2.397. Then you fail to reject the null hypothesis. And the last statement is exactly the same. So the only change is step number 3. Any questions, guys, about this? Okay, let me do one more with the critical value approach here. Just 1 second. I'm gonna do another exercise with you guys with the critical value approach. I'm gonna grab the book. A used car dealer says that the mean price of a 2-year-old sedan in good condition is at least $20,500. You suspect the claim is incorrect and find a random sample of 14 similar vehicles had a mean price of $19,850 and a standard deviation of 1,084. He didn't mention population standard deviation, you know it's S. Is there enough evidence to reject the claim? If he asks you a question about rejecting the claim, then you be sure that the claim is in the null hypothesis, because the language of reject, we only use it when the claim is in the null hypothesis. If he asks you, can you support a claim? Be sure, guys, that your claim is in the alternative hypothesis. Assume that the population is normally distributed. Okay, let's do this. I'm gonna do this exercise 2 ways, guys, by using critical value and p-value approach. Okay, let's do it with p-value first. So that will be an additional exercise, and this is a critical value. Both of them are gonna lead to the same conclusion, guys. Okay, both we have to write the null and the alternative. It says at least. You should agree with me that at least means greater than or equal to 20,500. So this is the claim. And HA, guys, mean is less than 20,500. N is 14, he says. Sample is 19,850 sample mean. S, he says it's 1,084, and he wants us to test that alpha equals 0.05. Okay, please help me and grab your calculator and let's run the t-test here. Stat. Oh, I need to quit. Stat. T-test. U0, we're testing against 20,500 guys. List is, oh, not data, sorry. It should be stats, summary. 20,000, X bar is 19,850. S is 1,084. And N is 14. And what is the alternative sign here is less than. Calculate. T is negative 2.24 for 4. P-value is what? 0.0215. This is all I need. And we're doing it with alpha 5%, guys, so it's less than. So you reject HO. Can a student tell me what the conclusion is? We reject HO and the claim is in HO. He says, is there enough evidence to reject the claim? Well, we reject HO and the claim is in HO. You want me to show you my yellow sheet? The claim is in HO and we reject HO. So what do we say? There is enough evidence to reject the claim. So we say, yes, there is enough evidence to reject the claim. So that's not what he did in the book. He used the critical value approach. So let me show you now the critical value approach. This is one way to do it. Now the critical value. Same steps, no changes. The claim is the claim, it doesn't change. These are given. T, in the critical value, they usually do it by hand, but you always can use the t-test to find it, guys. This is the formula, which is 19,850 minus the mean, 20,500, divided by S, which is 1,084 over square root of the sample size. And I'm not gonna do the math, guys, but I know the answer is negative 2.44. Same thing. Now critical value, watch. This is a left tail test, so I don't have two tails. I only have one tail at the left. So only one critical value right here, and this is alpha. Okay, and this is called T0, guys. I'm gonna find this one for you. Okay, look, how do you find it? I'm gonna go to table 5. Very straightforward, very easy to find. Degrees of freedom is 13, and alpha is 0.05. Watch. 13, and since this is one tail, so I look here, one tail, 0.05. So where does this take me? Okay, right here. 1.771. But remember, guys, I have a left tail test, so I'm not going to put 1.771, just make it negative. Negative 1.771. And then negative 2.244. Would you guys agree with me that the negative 2.244 is going to be right here? It's on the right because it's a smaller. This is T. So what do? It ended up in the rejection region. So the decision is what? Reject HO. And it's the same conclusion. There is enough evidence to reject the claim. Just let me show you here what he did. You see the negative 1.771, and this is T, negative 2.244. It ended up in the rejection region. You reject the null hypothesis. All right. So this is about the critical value, guys. There is only one question where we need to work with the critical value. So this is pretty much it for chapter 7. I'm going to start introducing chapter 8 right now using this handout. If you didn't download it today, print it please for tomorrow. Okay, so let me just give you a brief overview of chapter 8, and you're gonna see, guys, the same 5 steps. It's just gonna be pretty much the same. Step 1, 2, 3, 4, 5. Using my yellow sheet, to make a decision in step number 5. Nothing is going to change. The difference between 7 and 8, in 7 we worked only with one population. In 8 we're gonna work with 2 population. For example, a population of women and population of men, and we'll compare the 2 populations. So it's gonna require 2 samples. In chapter 7, we only work with 1 sample. In chapter 8, we will be working with 2 samples. That's the title of the chapter, Hypothesis Testing with 2 Samples. Okay, before I do that, I wanted to explain to you guys what is the difference between independent samples and dependent samples. We say that 2 samples are independent if one sample selected from one population is not related to the sample selected from the second population. This is an example, guys. You see, no relationship whatsoever. Now, 2 samples are dependent if each member of the sample, one sample relates to another member in the other sample. Watch this one, guys. The relationship. So if you can find relationships, then the samples are dependent. No relationships, the samples are independent. So let me walk you through some examples, guys, and please participate with me. I see you are very quiet today. And tell me, what do you think, whether the samples are dependent or independent? Sample 1, weights of 65 college students before their freshman year begins. Weights of the same 65 college students after their freshman year. What do you guys think? Okay, I got a response here. Dependence, and I do agree. Because it is the same student. We measure his or her weight before the school year and after the school year. So these are dependent. That is correct. When you are talking about the same person before and after, they are dependent. Okay, let's check the next one. Classify the pairs as independent or independent. Scores of 38 adult males on a psychological screening test for attention deficit disorder, and the scores of 50 adult females in a psychological screen test for attention deficit disorder. What do you guys think for this one? Let me see the responses. Independent, yes, I do agree. Let's do some more. Okay, I'm gonna just, from the book, I can't just put everything in the handout, guys, so we'll just refer to the book for a little bit. I got a few questions here. If you're taking notes, guys, and the videos, by the way, the videos on those chapters are very good. If you like to watch them under each section, they have some good videos in addition to my videos. On page 424, number 5. The maximum bench press weights for 53 football players, the maximum bench press weights for the same 53 football players after completing a weightlifting program. What do you guys think? Dependent, yes. Why it is important to know whether the sets are dependent or independent? Because 3 sections in this chapter deal with independent sets and 1 section deal with dependent. So you need to know the difference to know which section to refer to. Number 6, the IQ scores of 60 females, the IQ scores of 60 males. What do you guys think? Males, females, different. So would you guys agree they are independent? Yes. Number 7 and 8. The average speed of 23 power boats using an old hull design, the average speed of 14 power boats using a new hull design. So what do you guys think of number 7? Dependent or independent? Independent. And I'll give you guys a very easy clue to tell right away. If they don't have the same sample size, definitely they must be independent, because in order to be dependent, they have to be the same number of people before and after. But here he says 60 females, 60 males. They're different people, so that's why we say independent. One more, 8. The commute times for 10 workers when they use their own vehicles, the commute time of the same 10 workers when they use public transportation. Dependent. Very good, Julia. Okay. Let's go back. All right. You're going to see this is not going to be a hard chapter at all if you have a good grasp of hypothesis testing from chapter 7. Two statements, HO and HA. A statistical null hypothesis HO. It's a statistical hypothesis that usually states there is no difference between the parameters, and they will use those signs. Alternative hypothesis, it will use one of those 3 signs. And I told you guys, if you have an equal, you must have a not equal. If you have less than or equal, you have a greater. If you have a greater than or equal, you have a less. When you compare 2 means, guys, with independent samples, you're gonna have to label the means as mu1 and mu2. We labeled them in chapter 7 just as one mean mu. But because I have 2 population, I have to distinguish between the 2, so we'll call him 1 and 2. Your scenarios, guys, is to have one of those 3. Either mu1 equals mu2, then the alternative will be mu1 not equal to mu2. Mu1 is less than or equal to mu2, then mu1 will be greater than mu2. That's the second scenario, and this is the third scenario. So the nice thing about chapter 8, guys, you don't have to worry about putting numbers on the right. It's either select this one or that as your hypothesis. Regardless of where the claim is, you have to assume always that the null hypothesis is true until proven otherwise. I'm gonna just do an example, guys, take you right away to an example and show you how to work with independent samples. So we're gonna begin, guys, with the 2 sample z-test. We did z-test in chapter 7 for 1 sample when sigma is known. Now it's called 2 sample z-test. That means 2 sigmas are gonna be known. Sigma from the first population and sigma from the second population. So conditions of the test. Population standard deviations are known. They call them sigma 1 and sigma 2. Samples are randomly selected. Samples are independent, and the populations are normally distributed, or the sample sizes are more than 30. So either we require that the population to be bell-shaped or the sample size to have at least 30 elements in it. How to perform the test? I think you are familiar with it. You state HO and HA. You find the standardized test statistic Z. You calculate the p-value, no critical value in this chapter. Make a decision to reject HO or fail to reject HO. Interpret your decision in the context of the claim. And let me show you now. Let's put it to work, guys. So please pay attention and see how nicely this will transit, just to chapter 8 from chapter 7. A credit card watchdog group claims that there is a difference in the mean credit card debts of households in California and Illinois. The results of a random survey of 255 households from each state are shown here. The 2 samples are independent. Assume that sigma 1 is 1045 and sigma 2, that should be a sigma 2, guys, is 1350 for Illinois. Do the results support the group's claim? First of all, guys, can you tell me which set of hypotheses I need to choose? It says a credit card watch group claims that there is a difference in the mean credit card between the 2 states. So would it be this first, second, or third? Any ideas? Would a few students respond, please? First, second, or third? Equal and not equal. But what is the claim? Equal or not equal? It says they claim that there is a difference in the mean credit card. So you guys agree that not equal. Okay. We'll write this down. Are the conditions of the test met? Yes, they are. Let's see what the condition. Population standard deviation are known. They are known right here. Number 2, the samples are randomly selected. He says random. Samples are independent. He says they are independent. Population are normally distributed, or the sample size is more than 30. Well, look at the sample size, guys. It's 250, so it's more than 30. So they are all met. You probably won't be asked to verify the conditions of the test, but it's good to know when you can perform the test, guys. So let's look at the steps. You see how I put the steps for you here? So HO and HA. Mu1 is not equal to mu2. This is the claim. And mu1 is equal to mu2. That's the null hypothesis. Okay, guys, it is called two-sample z-test. Just like you did a z-test, now it's a two-sample z-test. And let me take you right away to it and show you how to do this one. Stat tests. It is number 3, guys, two-sample z-test. So when do we use a two-sample z-test? When sigma 1 and sigma 2 are known. That's section 8.1. Okay. Watch. He's asking you for sigma 1 and sigma 2. Let me show it to you. Sigma 1 is 1045 and sigma 2 is 1350. So let me put him there. Then he's asking you for x1 bar, which is 4777 from the first set, and the sample size is 250. Then x2 bar, guys, 4866, and the sample size is 250. Then he asks you to select the alternative hypothesis, just like you did in chapter 7. Well, the alternative hypothesis, you can see, guys, it's not equal to. So we select that one. Now it is selected. And then calculate. There you go. That's Z, and that's a p-value. I'll write them down, and I'm just back to chapter 7. $4098. Well, guys, this is bigger than alpha. It's bigger than alpha. I don't know what alpha is. 0.05. Failed to reject HO. And let me take you back to my yellow sheet and show you how we're going to write the conclusion. Claim is an HA. Fail to reject HO. There is not enough evidence to support the claim. As simple as that. There is not enough evidence at the 0.05 level of significance to support the claim. And what does the claim say? To support the claim that there is a difference in the mean credit card debts of households in California and Illinois. We cannot support this claim. Any questions, guys, about this one? Okay, I think we have time to do one more, and we'll wrap this up. All right. Example 2. A travel agency claimed that the average daily cost of meals and lodging for vacationing in Texas is less than the average daily cost in Virginia. So would you guys agree with me if I state, okay, Texas is labeled as 1 and Virginia is labeled as 2. Would you guys agree with me if I state them like that? This is HO. This is HA. Okay, he says Texas is less than Virginia. This is the claim. And this is greater than or equal to. Two samples are independent. Assume that sigma 1 is 9. Guys, once he gives you sigma, don't attempt to use a t-test. It's a z-test. If he doesn't give you sigma, it is a t-test. So assume that sigma 1 is 19 for Texas and sigma 2 is 24 for Virginia, and that both populations are normally distributed. At alpha equals 1%, is there enough evidence to support the claim? Once he asks you if you can support the claim, be assured that the claim must have been in HA, and it is. Okay, two sample z-test. Because sigma 1, sigma 2 are giving. All right, so let's run the test. Stat. Okay, sigma 1 is 19. Sigma 2 is 24. X1 bar, now I'm gonna start taking the data, 234. N1 is 25. 240. N2 is 20. And now you choose the alternative hypothesis. And this is it, guys, less than. Choose this one. Bingo. And let's do a draw here. It's a left tail test, so if there is a p-value, you'll see it on the left. Okay, so I got z is negative 0.91 and the p-value 1808. 1808, and I think you agree with me, guys, it is bigger than alpha. So you fail to reject HO. And conclusion, using my yellow sheet. Your claim is here. And you fail to reject HO. What do you say? There is not enough evidence to support the claim. So there is not enough evidence at the 0.01 level of significance to support the travel agency claim. That the average daily cost of meals and lodging for vacationing in Texas is less than that of Virginia. So in summary, guys, you perform a two-sample z-test for the difference between two means, mu1 and mu1 with independent samples when sigma 1 and sigma 2 are known. That concludes section 8.1, guys. We're done with this section. As I told you, you can start working on that section as well. And tomorrow we will complete 8.2, 8.3, and 8.4.